Hi, everyone, and welcome to our Intro to Xojo course. My name is Dana Brown. I'm the Director of Marketing at Xojo, and we're going to start our third chapter of the programming course. We will start looking at some of the features that allow us to execute a block of code, specifically as the result of a given comparison. Comparison operators are used to determine if two values are the same or different. This is something that for sure you'll need when writing your own apps. How can we do these kind of comparisons? When we need to compare two numeric values or even text values, we will use the comparison operators. The first of these operators is the one we already know from assigning values when working with variables. It is the equal symbol. In this case, its meaning is really the one we could expect from it. It compares the right side value against the left side value. So it can give us the result if both of these are equal or not. This is if the comparison between the two values is true or false. The second operator is the one in charge of letting us know if the value at the right side is smaller than the one at the left side of the operator. Of course, we can also find a comparison operator, letting us know if the value at the left side is smaller or equal to the one found at the right side of the operator, something that we can express using the combination of these two characters. If we want to know the value at the left side, if the left side is greater than the one at the right side of the operator, then we need to use the greater than operator, expressed by this character. And if we need to compare the left side value to see if it is greater than or equal to the one at the right side of the comparison operator, then we will use the combination of these two characters. These are the main or basic comparison operators. As a result of any of these comparisons, we will get to know what is a Boolean value. That is something that can only be true or false. In fact, in the Xojo language, we have a data type just to deal with these kind of Boolean values, meaning the ones that we get as the result of any given comparison between two or more logic expressions or simple values. As you may expect, the data type we are going to use to store these kind of Boolean values is named Boolean. So in order to declare a variable so it can store the Boolean values, we need to type the variable name as we did see in the previous lesson, and then the Boolean keyword for the data type. So remember, these kind of variables can only store true or false values. We already know the basic comparison operators and how to declare Boolean variables. But how can we use these to write comparison sentences? Well, this is something we can do using the if-then block. For that, we need to type the if keyword and then the comparison expression we want to use, in charge of returning a Boolean variable. And then the then keyword, so it delimits the start of the lines of code to execute when the comparison has been evaluated as true. Finally, to close or delimit the end of the block, we will use the end if keyword. So remember that if everything inside if, then, end if is seen as a block of code, that will be executed only if the comparison expression is evaluated to true. Also, all the variables declared inside of the block of code will have their scope local to the block, so we can't refer to these or access their stored value from the code written outside the if, then, end if block. In this example, the myLabel variable will be the local and its value only can be accessed from inside the block. In fact, this variable only will be declared if the comparison expression is evaluated as true. In the same way, the message box sentence only will be executed if the comparison is evaluated as true, and it can access the myLabel value because both lines of code are inside the same local scope defined by the if, then, end if block. If the comparison expression is evaluated as false, then the code execution will jump to the first line of code found after the end if keyword that closes the block of code. So it will be the only one displaying a message dialog. The main concepts here are, first, we can define a comparison block using this structure: if comparison expression, then the then keyword, and to close the block, the end if keyword. The second main concept, if the expression is evaluated as a true one, then the code inside the block will be executed from the top line to the bottom one until it finds the end if as the end of the block. Once the end of the block is reached, the code execution will continue with the first line after the end if keyword, executing, in this case, the line displaying a new dialog. Otherwise, if the comparison expression is evaluated as a false one, then the code execution will jump to the first sentence found after the end if keyword, displaying only the second of the dialogues. Once we know how this works, we already know how to compare two numeric values. It's time to return to our app where we had to type the birth year and the current year in order to calculate the current age. So now we will do this using comparison operators, and we will be able to display a message informing us of the current person's age based on its age, that is infancy, early childhood, middle childhood, etc. So how can we do this? Well, we already know that our result variable stores the value found as the result of the subtraction of the birth year from the current year, so it is stored as a double value. We could write the following comparison for those persons less than 0 years old than the early months of life, so we need to compare that our result value is less than 0. If this is the case, then it would execute the next line of code inside the block. As we want to follow comparing the result variable against other values, then we need to use the keyword allowing us to evaluate more comparison expressions. This one is the else if keyword. If this expression is evaluated as false, then it will execute the next comparison found as part of the same block in order to see if it is true. In this case, we want to know if the value is less than 5 years. So we need to compare that our result value is greater than 0 and also less than 5. For this, we need to use a new language keyword allowing us to evaluate 2 or more comparison expressions and check if all of them are evaluated as true. As you can guess, the name of this keyword is AND. So if we were to read the line of code, it would be, if, on the contrary, the result value is greater than 0 and the result value is less than 5, then execute the following lines of code. We were in the early childhood stage. If, on the contrary, the value of the result variable is greater than or equal to 5 years, then the result is less than 10 years. Then we would execute this line of code fragment. If, on the contrary, the result were greater than or equal to 10 years and the result was less than 12 years, then it would execute this snippet of code. We continue with our comparison expressions. If, on the contrary, the result were greater or equal than 12 years and the result were less than 18 years, then we would be talking about the adolescent stage. If, on the contrary, the result were equal or greater than 18 and also less than 65 years, then we would be at mature adulthood. And lastly, if it were any other value, observe that in this case, we only use the else keyword. Instead of chaining a new comparison expression, then this would be the late adulthood stage, and we will look at our comparison block using the end if keyword. As you can see, from if to end if, we can chain as many comparison expressions as we need using the else if keyword, or also the else keyword to attach any other not matching comparison, even for any of the optional additional comparison expressions. Let's display a dialog showing a different message for any of the included comparisons. And with the string data type, so we can assign a different value inside of every comparison block. This case would be the infancy stage, and this would be the early childhood. This could be middle childhood, and late childhood. We will be assigning the adolescent string value. And here it would be midlife. And last, assigning the mature adulthood string to it. After the if and if block, we type this statement to display the message box. Adding to the literal string message the string from the stage variable. Let's run our example app. Let's type 1990 as the birth year and 2020 as the current year. So the message box tells us that the person is in its adult stage. If we type 2019 as the birth year, then the message box will display the infancy stage. And if we type 1950, then that person would be in their mature adulthood stage. We can see more clearly how this works, setting a breakpoint. So we can access the debugger panel in the IDE when the code execution reaches the if line of code. You can see how I can return to the IDE even if the app is running and set any breakpoint I need. So if we click again on the calculate button, even without changing the current values, we can see how the IDE is brought to the front, displaying the debugger panel, where we can see that the result variable has the 70 value. We set our breakpoint on the initial comparison. And let's execute the code step by step. We can see how the result of this comparison will be false because the result value is greater than 0. And it jumps to the line inside the else block. That is the one matching the criteria when all of the previous comparisons have been evaluated as false or not matching. So it jumps inside the last one in charge of catching any other cases where the result value is greater than 65. The mature adulthood is assigned to the stage variable, and then the message dialog is displayed as we can see here in order to see other comparison cases. We can see how the first comparison is still evaluated as false because the result variable has the 30 value and it is greater than 0, then 5, then 10, then 12, then 18, and we will see this jump inside the comparison block where it is evaluated as true. This is the result value, and it's equal or greater than 18, and also less than 65. If we run the code step by step, we can see how it automatically jumps into the right comparison block. So the mature adulthood is assigned to the stage variable, and then it continues the execution after the end if statement. As I said at the beginning, once one of the comparison expressions is evaluated as true and the code inside that box is executed, then the rest of the comparison expressions wouldn't be evaluated and the code execution will continue in the first line of code after the end if. In fact, if we use the option in the debugger to execute the current line of code, we can see how, in effect, it will jump directly to the message box statement in charge of displaying the assigned string to the stage variable. So none of the comparison expressions after that one will be evaluated. In addition, when we work with these kind of conditional if and if structures, it is also possible to combine two or more of these. For example, we could use expressions like if result greater than 0 and result less than 100, then what's a nested expression? Well, it's when we include a conditional block inside an outer if-then conditional block. If the first condition is met, that is, the the value of the result is greater than 0 and less than 100, then we could nest a second if-then block to do a series of other comparisons. Here we compare the value of the result that is equal to 18, then, and even a third if-then block, where we can compare the value of the result variable in order to see if it is equal to 40, and a third block where we compare the value of the result against 65. And we could even look at a third level of nesting inside the last block. So you get the idea. You should try to avoid these kinds of comparison constructions because it tends to be unclear code and even is a little difficult to catch errors with all of these nested blocks of code and understand what variables are local to certain blocks of code and not to the outer ones. So let's get back to our initial code and remember that everything we declare inside a certain block of code will be local, that is accessible, just inside that block of code, and also inside, but not from any other code outside such block. So let's look through an example. Here we can see our stage variable declared as a string before the if and if block. But if we declare the stage variable inside of every comparison block, we'll see how our code wouldn't throw any variable duplicated error when we instruct the IDE to run it. But we're going to see if it will throw another kind of error. As you can see, we're using the same scheme inside every comparison, declaring the stage variable and assigning a new value to it. And if you remember from the previous lesson, we can't redefine a variable again because that would throw a compiling error. So why am I doing it here and it won't lead to an error when we instruct the IDE to run our app? Well, the answer is that these variables are treated as different ones because they are local and visible just inside their own block of code. So the scope of the variable is since the execution of the app enters the block until it runs the last line of that one block of code. If the comparison is met, then the execution of the app enters into the block, then the stage variable is declared just inside that block, and a new value is assigned to it. When it jumps outside the block, the variable is destroyed and thus not accessible. And this is the same case for every other block of code associated with every remaining comparison. So when the message box statement tries to access the variable content, this one is not available. That is an undeclared variable. If we run our app, we can see that this is exactly the error that is the variable does not exist, but we are trying to access it. Thus, this is something you need to take care of, so any variable declared with a local scope only will be accessible inside the block of code where they are being declared. As I said at the beginning, we can also compare text strings. Let's see how we can do this. If we add to our window the open event handler and we write a comparison expression, something like if Monday is less than Tuesday, then message box, Monday is less than Tuesday, else message box, Monday is greater than Tuesday. So how is the text comparison made? Well, it follows the alphabetical order, and such order doesn't make the difference between upper and lowercase. So it's the same if we type Monday with a capital M using the initial capital letter, or typing it as lowercase with all lowercase letters. That if we run the code step by step from the debugger, the comparison condition is met because the I is before M in alphabetical order. So of course the Monday goes before Tuesday, or less than the Tuesday, executing thus the following line of code. But if we change Monday to Wednesday, if we execute the same line of code now from the debugger, we can see how the V from the Spanish word Friday, because this video was originally recorded in Spanish, is greater than the M from the Spanish Tuesday, so the comparison expression is evaluated to false, and it jumps into the statement displaying the corresponding message. In fact, the comparison between strings is the starting point for our next example where we are going to learn the logic operators we need to know. Previously, we saw how the AND keyword let us change several comparison expressions, meaning that all of them have to be evaluated as true. So the first condition needs to be met, and the second condition also needs to be met, and any other condition also needs to be met. The OR keyword is about chaining two or more conditional expressions where only any of these needs to be evaluated as true. Let's see an example about how this works. Let's start with the layout of our user interface, where the user only needs to type the name of any object. Adding the action event handler to our button, as we already saw in a previous video. So let's say that if the typed value in the text field 1.value is equal to apple, or if the value typed in the text field is equal to pear, or the value typed in the text field is equal to orange, then it will display a dialog with the message, the typed value is a fruit. Then we can add an else if text field 1 value is equal to computer, or text field 1 value is equal to phone, or text field 1 value is equal to TV. Then it will display a dialog with the message the typed value is an object. And for any other case that doesn't fit in the previous comparisons, it will display a dialog with the message, I don't know what it can be. If we want to run our app at this point and we type keyboard, let's put a breakpoint in the code. We can see how none of the comparisons are met, so it jumps directly into the else block. If we type orange, it will meet the first condition when it matches against one of the cases chained by the OR keyword, and it will run the code inside that particular block. And if we type TV, then it will match one of the conditions specified in the second comparison. So as you can see, the use of comparison blocks are really very versatile in order to execute a block of code or another one in the base of a given value. But if, then, and if is not the only comparison structure. In fact, in many cases, it's more useful to use the select case structure combined with the end select keyword to establish the end of the block. We need to provide an expression or variable to select case that will be used as the source value against what we want to compare. We are going to use a numeric variable for this, so one storing the day of the week value and then setting a series of values that will be compared against the one stored in the source variable. So let's declare our day of week variable as an integer data type, and that will be storing the value from text field 1.value converted from string to integer via the toInteger method. Then we can type case 1, case 2, case 3, case 4, case 5, case 6, and case 7. So we can put into our kind of day variable a string data type. So if the day of the week matches against the case 1 condition, then kind of day will be assigned the labelable string value, which means working string value. The same for the case 2 condition, the third one, the fourth one, the fifth one. While if the value matches against 6 or 7, then kind of day will be assigned the weekend value. And then we will display a message box showing the kind of day. If we run our code at this point, when we type, for example, the 3 value, so it's the Wednesday day, the third day of the week for many countries, then we'll get a dialog telling us that it's a laborable or working day. If we type the 6th number, that is Saturday in many countries, then the dialog will tell us that it is a weekend day. But the select case is more flexible, so let's make use of that in our code. As you can see, right now we're using a line for every case, but we can express this the same in a more compact way. Let's see one of these next, where we can combine several values under one same case, which means that the statements inside the comparison block will be executed if any of the case values match against the expression or variable we want to compare against. So we can type case 1, 2, 3, 4, 5 to execute the same code for any of the labelable days, and case 6, 7 to execute the weekend code. Let's run our app again. So if we type 5, then it would match against the first case, while if we type the number 7, then it will match against the second case, and it will display the weekend message in the dialog. But the select case also provides more flexibility. We can express a range of consecutive values to be evaluated in a particular case. So we can optimize all of the labelable or working days comparison by typing the initial value of the range for the to keyword, and then the last value of the range, and also the same for the weekend values. Although in this case it wouldn't make much sense because they are just two consecutive values. We run our app again and type the number 4, so it will match the first case range and will display the labelable message. While if we type the number 6, it will match the second case comparison, displaying the weekend message. In addition, we also can use the comparison operators we learned from the beginning of this lesson. For this, we need to make use of the is keyword, and then type the comparison expression we saw for the if and if block. So we can type here the less than sign 6, that is, for any value less than 6, we will assign the labelable string to the kind of day variable. While in the second case, we will compare against all of the values greater than 5 or equal to or greater than 6, so it will assign the weekend string to the kind of day variable. We run our app again, and if we type the 5 value, it will display the labelable message, while if we type the 7 value, it will display the weekend message. The best thing about the select case and select comparison structure is that we can combine all of the supported expressions, individual values with a range, or even any of these in combination with a comparison that uses the comparison operators. We can compare against 1, 2, 3 as individual values, and also 4 to 5 as a range of values. And that's all for this lesson. We learned about blocks of code, the comparison structure using if-then and select case. We also learned about the comparison operators, some of the available logic operators like and or, and the Boolean data type. Please subscribe to our channel to be notified when more videos are posted, and feel free to ask any questions below. Thanks for watching!